In section 3.5, we're going to be looking at the real zeros of polynomials. And so we're going to pick up this idea here of the rational roots theorem. And this is going to be a really good tool and guide for us to be able to break down polynomials, unlike of what we saw at the end of section 4, where we gave a factor or zero to get us started. This will be one where we're going to start from no factors to zeros and work our way through it. So it says, given a polynomial f of x with integer coefficients, meaning numbers like -1, 1, 0, etc. If r is a rational zero, meaning it can be written as a fraction of f, then r is in the form of r equals plus or minus p over q, where p is a factor of the constant term and q is a factor of the leading coefficient. So here's what this is saying. This front number here is known as your leading coefficient. And then if we're looking at the back constant term, this number here is known as your constant term. And so what the rational roots theorem says is if we take our constant, we're going to call it p, and we take our lead coefficient, we're going to call it q, and we look at the factors of p, or of our constant term, over the factors of the leading coefficient, this is going to give us the possibilities of what the zeros would be. And we always look at the positive or negative of it, because we're not going to try and figure out was it positive or was it negative. We're just going to look at all the factors and start kind of analyzing, looking at what could the possibilities of what it would be. And so let me read it again. It says, given the polynomial, if r is a rational zero, so this is only going to find rational zeros, it will not find imaginaries. And then r is in the form of p over q, where p is a factor of the constant term and q is the factor of the leading coefficient. Then we can find, again, all the possibilities. It does not guarantee that they are there, but if they are rational, they are going to be in that lineup. So let's look at this example and see what we can do with it. Example 1, let f of x equal 2x to the fourth plus 4x cubed minus x squared minus 6x minus 3. Use the rational roots theorem to list all possible rational zeros. So we're just going to list out what our possibilities could be. And so what I'm going to do is I'm going to look at my front coefficient 2, and I'm going to look at my back term 3, and it's irrelevant whether it's -3 or not because we're going to do plus or minus. And so the possible zeros are going to be plus or minus the factors of p over the factors of q. And so we're going to say, okay, what are the factors of p? Here's our p back here, and here's our q up here. Factors of 3, things that'll multiply and give you 3, are only 1 and 3. There's no other factors. I like to list them in order to make sure I don't miss any. Factors of 2, or my q, would be 1 and 2. There's no other numbers that would multiply to give you 2. Now this is set up as a fraction, so what we're going to do now is we are going to take everything in the top and divide it by 1. And then I'm going to take everything in the top and divide it by 2. And so what you're doing is dividing all of your numbers in the top by every number in the bottom. And I try to go systematically so that I don't miss one. And so I'm going to say 1 divided by 1, so it would be plus or minus 1. 3 divided by 1, so it would be plus or minus 3. 1 divided by 2 would be plus or minus 1/2. 3 divided by 2, so it would be plus or minus 3 over 2. And so this would give me all the possibilities of what the zero could be. Now at the end of the day, this is just a 4-3 polynomial, so only 4 of those will work. They could even repeat, and I could even have some imaginary ones in there. But those are going to be all my possibilities. Now let's find all the zeros of it. So we're going to use our synthetic to help us with that. So I'm going to draw my synthetic. So this would be 2, 4, -1, -6, -3. And then I want to try some options. And so from my options, just looking at my list, I'm going to go ahead and try -1 and see how this works. Now I'll know if it works if right here as the remainder I get 0. So I'm going to quickly do my synthetic. and that works. That gave me a 0. Now, whenever you're working through this, you could have multiples of it, just like what we saw with multiplicities. And so I'm going to go ahead and try -1 again. And again, we get a remainder of 0. Now remember where we started. This was an x to the 4th. This was an x cubed. So this is an x squared. So once I get to this point, I'm going to write whatever I have left over, 2x squared minus 3 equal to 0. And I'm just going to solve that out. So 2x squared equal to 3. Divide. I get x squared equal to 3/2 and then square root. So x is equal to plus or minus the square root of 3/2. Simplifying that up, that would be square root of 3 over square root of 2. So I'm going to rationalize out that radical in the bottom. That would give me square root of 6/2, and don't forget our plus or minus. So what are our zeros of this function? They are x equal to -1, -1, square root of 6/2, and negative square root of 6/2. And you can see we had a 4th degree and we got 4 zeros. Now, after all this is said and done, let's go back and look at that graph. This is the graph of the whole function. And we don't typically look at graphs, but I just want to reiterate what's going on here. So if we look at this graph here, you can see that it's crossing at -1. You can see it's crossing at a little bit more than 1. And if we zoom in on this graph, you can see that it's passing through right here. That's that negative square root of 6/2. And so since it's passing through, it has a multiplicity of 1. And then right here it's touching. And so this is that x equal to -1. And that has that multiplicity of 2. And then right here is that square root of 6/2. And so this rational roots theorem is going to be helpful as we work through our polynomials, because we don't want to have to take your graph it, look at it, zoom in at those values. Let's go through another example. Let f of x equal -2x cubed plus 19x squared minus 49x plus 20. And it says use the rational roots theorem to list all the possible rational zeros. And so you want to do your p over q. And so our possibilities are going to be the factors of p over q. So if p is 20, that means the factors would be 1 and 20, 2 and 10. 3 doesn't work, but 4 and 5 work, and there's no numbers or integers between 4 and 5, so that's my entire list, over the factors of q, which are 1 and 2. And then I'm going to divide all those out. So I'm going to take everything on top, divide it by 1. So that would be 1, 2, 4, 5, 10, and 20. I'm going to take all those factors, divide it by 2, and so that would be 1/2. 2 over 2 is 1, and I already have it listed. 4 over 2 is 2, and I already have it listed. 5 over 2, 10 over 2 is 5, so I'm not going to write it again, and 20 over 2, which is 10, so I don't want to write that again. So this would be all my possible rational zeros. Then from that list, I'm going to now find all my zeros of it. So I'm going to first do synthetic. So this would be -2, 19, -49, and +20. Now when you're looking at a polynomial and you're trying to figure out, okay, what could possibly be a root of it, here's what I advise. First, I would look at your sign. Since I do have some negatives in here, I am going to start with a positive. Then we'll look at my numbers. Since they're getting really big, I'm probably not going to start with 1 or 1/2, because those would make my number smaller as I'm multiplying. So let me just kind of start here in the middle and start with 4. Working through synthetic, I'm going to bring down the -2, multiply, add. If I get to this end point and it's not a zeros remainder, I'm just going to restart and try another option. So I'm going to multiply, add, multiply, add, and this works out for me. Now, whenever I get to a problem and I'm able to get it down to a quadratic like I have here, I'm going to go ahead and write out my quadratic, because if I can get it down to a quadratic form, I can either use factoring or quadratic formula to go ahead and fill that out. Now for this one does factor. This factors into negative 2x, and x will multiply, give me negative 2x squared. And 1 and 5, negative positive, will multiply to give me that negative 5 in the back, and give me the combination of 11x. And so then that would give me x minus 4 out front here. These would be my factors. And then if I set them equal to 0, I have x minus 4 equal to 0, so x would be 4. Negative 2x plus 1 equals 0, so let's see, negative 2x equal to negative 1, so x is 1/2. X minus 5 equal to 0, so x would be equal to 5. And so what are the zeros of this function? 4, 1/2, and 5. And you can see I have 4, 1/2, and 5. So any of those three options would have got me going with figuring out what the zeros of this function are. So I hope this helps as you're looking through 3.5.